Question 8 states that acetic acid is extracted from water into hexanol in a liquid-liquid extraction vessel. After that, the extract is subsequently separated by distillation. Assume that water is completely insoluble in hexanol. A mixture of 18% weight acetic acid and the balanced water is fed to the liquid-liquid extraction vessel. Pure hexanol is fed into the vessel to extract the acetic acid. The water-rich stream leaving the vessel is 99.5% weight water and the balanced acetic acid. The hexanol-rich extract from the vessel is fed to the distillation column. The composition of the distillate is 4% weight hexanol and the balanced acetic acid.
For question A, we need to draw a process flowchart completely. The question states that acetic acid and water is being fed to the process. We are given that the mass fraction of the acid is 0.18 and if the balance is water, we know that the mass fraction need to sum up to 1. So, the mass fraction for water must be 0.82. The question states that the other feed to liquid-liquid extraction column is pure hexanol. From the question, we don't have any flow rate given, so we will label the stream with M1 and M2. The water-rich stream that leave the extraction column is 99.5 weight water and 0.05 weight acetic acid, and we label it with M3. The hexanol-rich extract leaving the extraction column is fed to distillation column. The question does not give any information about the composition, so we are going to label it M4 and unknown composition variable to represent the mass fraction for hexanol and acetic acid, and also there is no water in this stream. We also don't have information about the composition for both distillate and the bottom stream. Composition for distillate is 96% acetic acid and the balance is hexanol. The bottom stream is 97.2% hexanol and the balance is acetic acid.
For question B, write a basis for this process and what are the significance of this basis. Give 2 reasons. The basis that we use in this process is 1000 kg per hour of hexanol. The significance of the basis is first, to give the process a standard measurement and make it simple to compare different operating conditions or variation. Second, make it easier to determine material balance and process efficiency.
First, we need to calculate overall balance. Overall balance M1 plus M2 equal to M3 plus M5 plus M6. M1 equal to 1000, so 1000 plus M2 equal to M3 plus M5 plus 977.37. After that, 0.95 times with M1, we get 0.972 times M6. Then we substitute M1 equal to 1000 and then we get 0.972 M6. Then we can get M6 equal to 977.37. And then for CB, H, we can calculate 1 times 1000 equal to 0.05 times M5 plus 0.972 times M6. We can substitute M6 equal to 977.37 that we get before. So 1000 equal to 0.04 times M5 plus 950. We can get M5 equal to 1250. For A, we can calculate 0.18 times M2 equal to 0.05 times M3 plus 0.96 times M5 plus 0.028 times M6. M5 we can substitute equal to 1250 and M6 we can substitute with 977.37. So we can get W equal to 0.82 times M2 equal to 0.95 times M3. So we can get M2 equal to 0.95 times M3 over 0.82. Then M2 we can get 8971.03. M3 we can get 7743.66. We get the value from 1000 plus 0.95 times M3 over 0.82 equal to M3 plus 1250 plus 977.37. If the bottom stream contains 97.2 of hexanol and recover 95% of the hexanol fed to the liquid extraction vessel, determine the percentage of the acetic acid in the process feed that is recovered in the distilled stream. So, for the answer, we can calculate that M6 times with 0.028 over M4 times 0.55. M6 we can substitute with 977.37 and M4 we can substitute with 227.37 and 0.55 we get from 1 minus X. And then after that we multiply it with 100% and then we can get 2.33%. For the last question, determine the mass fraction of each component in the hexanol-rich extract system. So, we calculate with 1000 equal to M4 times X. And we can get X equal to 0.45. So, XH equal to 0.45 kgH per kg. For XA, we can get 0.55 kg A per kg. We get 0.55 from 1 minus 0.45.